Hello, I am Jeevan from Group 5A, here to present about shaping plastics. My team is assigned to present and propose about chapter 5, that is shaping the plastics. I myself, Jeevan, son of Ganesan, material number CD150134. I'll present about the introduction and the extrusion process. Okay, what we do understand about plastic is that it is a very important material that we use in our daily lives. Now we will see how to process the plastics. Okay, plastics can be shaped into a wide variety of products: molded parts, extruded sections, films, sheets, insulation coatings, fiber for textiles. Okay, almost unlimited variety of part geometries. It may be on very different geometries and shapes. Plastic molding is a net shape process. Plastic molding is a shaping process where we can shape the plastic into our desired shapes. Further shaping is not needed. Once the shaping is done, we don't have to carry out another process like metal. Less energy is required than for metals due to much power, much lower processing temperatures. Unlike metals, it requires a very low temperature in order to melt so that we can process it into another shape. Handling of product is simplified during production because of lower temperatures. It can be handled very fast because it needs less time to heat up and less time to cool down. Painting or plating is usually not required. The surface of the plastics usually very smooth, so it doesn't need a coating process like metals, like painting or coating, because it is very smooth. Okay, in plastics there are two types of plastics, that is thermoplastics and thermosets. The difference between thermoplastic and thermosets are chemical structure remains unchanged during heating and shaping. The thermoplastics can be reheated and reprocessed in order to achieve another product. But for the thermosets, the shaping process of the first process is it changes the chemical structure of the thermosets, so it cannot be reheated and remelted, so it can be used only once. In example, for this, the thermoplastics are examples of pipes, but the thermosets are the examples of plastic cups that we use. It cannot be remelted and be reused. Another example is that thermosets are the example of polyurethane foams, and the thermoplastics are the examples for bumper of cars or other materials that we use on daily lives. Okay, to shape a thermoplastic polymer, it must be heated so that it softens to the consistency of a liquid. Two things are very important for the thermoplastic, that is the viscosity and the viscoelasticity. Viscosity means it can flow in a shape so that it can be formed into our desired shape. Viscoelasticity, it means the plastic, it remembers the original position and expands a bit when it is let through the die. An example, in this, they let through in the die and then it expands a bit, so it becomes a continuous round shaped material. Okay, now we will see about the extrusion process. The extrusion is one of the process where they shape the plastic into rolls. It is a compression process in which material is forced to flow through a die orifice to provide long continuous product whose cross-sectional shape is determined by the shape of the orifice or die. Widely used for thermoplastic and elastomers to mass produced items such as tubing, piping, hose, structural shapes, sheet and film, continuous filaments and coated electrical wire. All these needs continuous coatings. So we can use the extrusion process. Some coatings needs, let's say a chair. A chair needs a mold which we will heat the plastic and pour it into the mold, and then we can shape the plastic. But for continuous process like coating a wire, we need extrusion process because the extrusion process produces long structures. Okay, the important parts of the extrusion. First, we have a barrel and a screw. A barrel is the whole case of the extrusion, and the screw. Both these items are very important because it plays with compression of the plastics. Another one is the feed section, the compression section, and the metering section. The feed section is where the plastic is inserted in more of a like powder substance. In the compression, it compresses the plastic into a more complex state, and in the metering section, it becomes a fully solid section, where after this, they will let go into the die and then extrude it as the shape that we need. Okay, this is the full section of the extruder. There is a feeder, the metering pump. After the metering pump, they will let go into the water for it to cool down. After that, it will be a finished product. Okay, these shows for different sections. Like the first one shows the hollow cross section. The second one shows the solid cross section. The process of the extrusion is all the same, but the requirement that we need, either it is hollow or it is solid, depends on the die that we use. You can see that all that are same for both the sections, but then in the die section, the hollow cross section, they have two openings. It means in the middle they have a thing that separates the plastic into a hollow section. For this, they don't have anything, so it will come out straight as the shape is projected here. Okay, this shows how the wire coating are done. It is the same process, but then the wire will be lagging in this side, and then it will go in a very high velocity. When it goes here, the plastic will be extruded, and then the coating will be done immediately, and that's how our wires are done. Okay, now let us see a video to enhance our knowledge more on plastic extrusion.
Now let's look at the inside of an extruder to see how it works. The plastic raw material in this hopper travels by gravity to the feed throat and drops onto the rotating screw. The rotation of the screw conveys the plastic forward through the heated barrel. As the plastic is conveyed forward along the screw, the channel depth decreases, forcing the plastic through a smaller area. The combination of compression and screw rotation causes friction, which generates heat. This is called shear heating. This heat, along with the heat from the barrel heating system, melts the plastic. By the time the plastic is conveyed to the end of the screw, it should be well mixed and at a proper temperature and pressure needed by the die. The plastic is called a melt at this stage. Beyond the screw, there can be a screen pack. The screen pack is a set of wire mesh filters that the plastic must flow through. The screens are typically from 20 to 100 mesh, which indicates the wires per inch. The screen pack is supported by a breaker plate, which is a sturdy metal plate with many holes for the plastic to pass through. The screen pack filters contaminants from the melt. The screen pack must be set in place with a coarsest screen next to the breaker plate, so each screen can support a finer one. Otherwise, the pressure difference may break the fine wires, contaminating the product and possibly doing permanent damage to the die.
Okay, that's all for my presentation. Thank you.